guys, welcome back. So what we're looking at today is 6.1 Leaping Lizards. So this is from your new workbook. So we are into a new workbook starting with chapter 6. All right, let's go ahead and jump right in. All right, so for this first part, we're looking at the Pythagorean theorem. So for each of the following right triangles, determine the measure of the missing side. Leave the measures in exact form if irrational. So that means we don't want to get any decimals for these. Now, the Pythagorean theorem is a squared plus b squared equals c squared, if you don't remember. When we have a right triangle whose legs, the two sides that form the right angle, are A and B, and the hypotenuse, the side across from the right angle, is C. So the one that we're going to take and do, what's it two? Number 3. So we're given the hypotenuse in one of the bases. So we've got 1 squared plus b squared equals 4 squared. 4 squared is 16, 1 squared is 1 plus b squared. Subtract the 1 away. So we have b squared equals 15. We take the square root. Now, is 15 a perfect square? No, it's not. So that means b equals the square root of 15. We leave it just like that. Do not give me the decimal. All right, the next one we're going to take a look at is number 4. So notice in 4, 5, and 6, one of our sides, our hypotenuse in each case actually, has a root over it. So it's already a radical. Don't worry, it actually is rather easy to deal with. So for this one here, we've got one of our legs and our hypotenuse. So 3 squared plus b squared equals the square root of 10 squared. 3 squared is 9 plus b squared equals. Now when we have a square root squared, they cancel each other out. So we're just left with 10. We subtract 9. So b squared equals 1. The square root of 1 is just 1. So b equals 1. So that's what the 4, 5, and 6 are going to be like. You're going to take and be looking at canceling out the root when you square it. So your number is just going to be exactly what's underneath there that you'll subtract the other leg squared value from. Okay? All right. The next part, transformations. Transformations is your keyword for this lesson, transformations. So transform points as indicated in the exercises below. So for A, we want to take and rotate point A around the origin 90 degrees clockwise and label it A prime. So in order to rotate 90 degrees clockwise, so this would be clockwise, there's a rule that we can use. So we can take what this point is and just switch its coordinates and change the signs to get our new value. So point A, so A is the point 4, 1. In order to take and get A prime, we're going to take and make our y value negative and our x value, oops, not negative, wrong one, negative. We're going to make our x value negative and keep our y value the same. So we switch them around. Y becomes our x. So that means we're going to have 1, comma. Now, our x value needs to become negative. So 4 is going to become negative 4. So the point 1, negative 4 is right here. And that is a 90 degree rotation about the origin. Let me make that a little bigger. Okay, so that is our A prime. All right, so now for A double prime, or B, reflect A over the x-axis. Label it A double prime. So how far is A from the x-axis? It's 1 above it, so we go 1 below it, and that is where A double prime will be. So there's our A double prime. and it has the coordinates for -1. And then last but not least, apply the rule x minus 2, y minus 5 to the point A and label it A triple prime. So that means we're taking our x value and subtracting 2. So 4 minus 2 is 2, and y minus 5, so 1 minus 5 is -4. So now we take and plot this. So we come over to 2, and we go down to -4. So that point right there is our A triple prime. A triple prime. So same idea for what you're going to do on 8. Some of them are a little different, but a 180-degree rotation just means you're switching the signs on your x and y values from the original coordinate, reflecting over this line. See how you get to it, and then do the same thing to the other side. Okay? All right. And the last part, graphing linear equations. Graph each function on the coordinate grid provided. Extend the line as far as the grid will allow. And then you're going to graph each, and then the last one will be, what are the similarities and differences between the two? So we're going to look at 12 and 13. So these have a fraction for a slope, each of them do. So on this first one, we have a slope of 2/3 x and then y-intercept of 1. So we're going to start at 1. I'm going to zoom this way in so you can see a little better. So we have a y-intercept of 1. The slope 2/3 means we go up 2 and over 1, 2, 3. And we go up 2 and over 1, 2, 3. And we can come back here and go down 2 and to the left 3. Down 2 and to the left 3. So there's our line. I'll draw it in a little better in a second. Now our second one, also y-intercept at 1. So that's something they have in common. But here we're going down 3 and over 2. So we go down 1, 2, 3, over 2. Go down 1, 2, 3, and over 2. And then go up 1, 2, 3, and over 2. And 1, 2, 3, over 2. I know that one went off the graph, but it makes it a little easier. All right, so now we're going to draw the line that goes between all of these. Hopefully I can draw it. So there would be our line for h of x, and this would be our line for k of x. All right, so for 14, it says, what are similarities and differences? What similarities and differences are there between the equations? Well, like we said, same y-intercept. That's the exact thing. What do we notice? Is there anything else the same? No, one's going up and to the right, the other's going down and to the right. So we have one positive and one negative slope. What else do we notice? What about their slopes? So this one is 2/3 and this one is a -3/2. What do we call that when we have slopes like that? They are opposite reciprocal slopes. And if we would have graphed these on the same coordinate plane, they actually would have intersected at a 90-degree angle and been perpendicular to each other. But we didn't do that, so it's not as easy to see. But opposite reciprocal slopes are always perpendicular lines. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.